afternoon, everybody, and welcome to this session. Today, we're going to be talking about machine learning options for mobile developers. I'm Laurence Moroney. I'm an AI advocate at Google.
And I'm Ibrahim from the Firebase Developer Relations team.
So we get a lot of feedback from developers, and particularly mobile developers, about there are just so many options when it comes to machine learning. Even at Google, we've got all of these options. You've probably seen lots of this today. You walk around the expo hall, you see Cloud has a number of offerings. We've got Firebase ML Kit. We've got TensorFlow. Android has some offerings. And we get a lot of feedback about how confusing that is. And somebody who's a mobile developer who just really wants to take advantage of machine learning, build that into their mobile applications, they need a roadmap. They need to figure out what do they do, which offering do they use, which product do they use. So what we're here today to talk about is to hopefully to try and clear that up a little bit, hopefully help you understand what the choices are when you would make particular choices. So the question, of course, is, OK, well, where do I start? What can machine learning, I sometimes say machine language, but that's a different thing. What can machine learning do for me, and really, why should I care? So I always like to level set before I go into some of the offerings of machine learning and just talk a little bit about what machine learning is anyway and how we think about it at Google and why we're so excited about it. So to me, first of all, when you think about machine learning, we're in the middle of this massive hype cycle around it. You probably see graphics like these in blog posts and news articles all the time. And they're just generally talking about machine learning will do this, and machine learning will do that, and machine learning will change the world, and machine learning will take away our jobs. And there's generally a lot of hype around this, and there's a lot of just hyperbole going on around machine learning. So what I wanted to do is level set a little bit and say, well, here's why this is going on. So first of all, this chart is the typical hype cycle around a new technology. Now, typically, it starts with a technology trigger. And that technology trigger then will lead to something that we call the peak of inflated expectations. And it's because of that peak of inflated expectations that we're getting all those kind of news stories that I mentioned on the previous slide. After we pass through the peak of expectations, we tend to fall into something called the trough of disillusionment, after which enlightenment will come and then productivity. So as an example of this, remember back in 2007 when Steve Jobs came on stage and he said, one more thing, and he introduced the iPhone. What happened after that was the peak of inflated expectations. The iPhone, the cell phone, was going to do away with everything. We wouldn't need desktop computers anymore. We wouldn't need laptop computers anymore. All we would need is one of these devices in our pocket, and it would do everything. And while those devices were revolutionary, and we all have smartphones, or most of us have smartphones now, they didn't replace the desktop. They didn't replace the laptop. We went through that peak of inflated expectations. And then once the trough of disillusionment hit, when people realized, OK, this is what I can do with a smartphone. Smartphone has a small screen. The smartphone is touch first. It has limited battery life. There are various things that I have to still be able to do on a desktop that I can't do on a smartphone. Then productivity set in. And new businesses came out of that. Things like Uber, right? Can you imagine trying to call an Uber on your laptop? It just wouldn't work. So when that trough of disillusionment was hit, and people then began to be enlightened about what it is that you can do with the smartphone, then productivity hit in. So when it comes to machine learning, when it comes to AI, I think we're right about here right now. We're still heading towards the peak of inflated expectations. And I like to joke that my job as an AI advocate is to tunnel you through that peak and get you straight to disillusionment. So I'm here today as a professional disillusioner, so please forgive me if I'm a downer with that. So let me talk about one particular example. Think about something like activity detection. Now, I'm curious, sometimes at Next we have a lot of coders. Sometimes we have a lot of people who aren't coders. Out of curiosity, how many of you are actual coders here, just by show of hands? Oh, wow, almost all of you. OK, cool. So think about something like activity detection if you're writing code. Like take, for example, I want to say I have a sensor that's giving me the speed at which I'm moving. So I can say, you know what, if my speed is less than 4 miles an hour, I can set my status as walking in code like this. But now I want to add biking to that. Running to that. So now it's like, OK, if my speed is less than 4, then I'm walking. Otherwise, I'm running. And now say I want to add biking to that. So if my speed is less than 4, I'm walking. If it's less than 12, I'm running. Otherwise, I'm biking. It's a basic algorithm, and it kind of works. But then my boss, who loves golf, wants me to add golf to it. All I can say is, oh, crap. How do I write an algorithm for that? Like when I hit a golf ball, it goes about 3 yards, so I walk this far. But when Ibrahim hits a golf ball, he will hit it, what, 200 yards, 250?
Maybe.
So it's like the algorithm for him will be a lot different from me, and we end up not being able to write a reliable activity detection. I know this is a very naive algorithm based on speed, but hopefully it gets the point across. So how do we solve something like this? Well, that's the idea behind machine learning and how we like to think of machine learning at Google. So first of all, if we talk about traditional programming is you express rules in a programming language, maybe Java, maybe C++, maybe JavaScript, whatever. Those rules will act on data, and then out of that you'll get answers. Like I had earlier on, if speed is less than 4, then I'm walking. That's traditional programming and as high level as I can actually draw it. So machine learning, the idea behind that is we flip the axes on this chart, and we end up saying, well, what if we have a whole bunch of answers, and then we have data associated with those answers, and then we have a machine actually learn the rules itself, as opposed to me as a programmer trying to express those rules. Then some of the limited scenarios and some of the difficulties in a scenario like activity detection that I mentioned, they could be fixed by saying, I can get a whole bunch of people walking, and I can say this is what walking looks like. I can get a bunch of people running and say this is what running looks like, this is what biking looks like, and yeah, sort of, this is what golfing looks like. So the idea behind machine learning is if I get all of that data, then it's just really as simple as I can have a computer start sifting through this data and spot the patterns that make a commonality for walking, spot the patterns that make a commonality for running, biking, golfing, all that kind of stuff. So the framework that we've built around this is called TensorFlow, and TensorFlow is what I work on. Whoops, slightly broken animation there. You didn't see that. So going back to this diagram that I showed you earlier on, machine learning, we think about it as we're feeding in the answers, we're feeding in the data, we write some code in a framework like TensorFlow that matches the answers to the data and then infers the rules out of that. What that will do is build what we call a model, and a model is effectively a neural network. It's a really badly named technology between you and me because it's got nothing to do with the brain, and sometimes it makes you think it's a lot smarter than it is. But if you think of a neural network, it's basically a bunch of interconnected functions, and each of these interconnected functions calculate a probability based on their inputs. But what that will end up giving us is a model. And then at runtime, we're going to pass data into the model, and it will give us an inference or a prediction out of that. So now, again, when I was thinking of my activity detection, I've trained it on a lot of people saying what it looks like to walk, run, bike, and golf. Now I'm going to pass it a bunch of data, and it will say, I think this looks like walking. Instead of me writing code, this inference is happening based on that data pattern matching. So building these models is what we call the training phase. So as we're creating a model, as we're passing it the data, as we're making a neural network to sift through that data to come up with the patterns that determine one thing over another, we call that training. And then at runtime, we call that inference. So the idea now is OK, now I know kind of what machine learning is all about. What do I do? Where should I run my inference? And Ibrahim's going to tell us all about that.
So now we have the question, where should I do my inference? Well, we have two options here. We can do the inference on the cloud or locally on the device. Why I might do it in the cloud? If you want to integrate into an existing cloud service, or you may want to use large, complex models that wouldn't be able to fit in a mobile device, or you want to use actually aggregate learning from a wide variety of sources. And using the cloud, you can actually minimize the impact on mobile battery and support less performant older devices. But what about the case for on-device? With on-device, you'll be able to keep the data local and avoid round-trip latency. This is particularly useful on real-time applications, where you want to process multiple frames in a quick succession. And sometimes you want your app to work even when it's disconnected. And you want to reach users without reliable or affordable connectivity. And this time, you will be able to actually, on-device is a much better inference type. And Laurence will go through the options that Google provide here.
Thanks. So again, thinking about your inference, you've built a model, you want to run inference on it, and as Ibrahim said, there's two choices. You can either run it in the cloud or you can run it on device. So let's first look at if you're going to be running your inference in the cloud, so you're not deploying a model to the device. Here's where you see all the cloud-based inference and stuff that you've been seeing at this conference today. So cloud-based inference from Google, there's three pillars. There's computer vision-based stuff that we call Sight. There's language-based stuff for translation and NLP, and then there's conversational-based stuff. So these are models that have been built by Google and services that have been provided by Google, so that if you're meeting these three scenarios and you want to run inference in the cloud, on these three scenarios, it's available to you. Now, in addition to that, the models that we've built, of course, can be customized. So the customization of these models come through the product called AutoML. So you see, like AutoML Vision allows you to retrain Google's computer vision model to recognize your needs. For example, you're a manufacturer who makes widgets, and you want some kind of computer vision solution that recognizes widgets, you could use AutoML to retrain it based on your widgets. Or in language, for example, if you want to do translation, so translation from language to language with machine translation, it can be pretty good. It's getting better all the time, but it's trained on a very general set. Again, you might be a manufacturer building something that has a specific language associated with it. Maybe your widgets have particular things associated with the widgets themselves that don't translate properly. You could retrain the machine translation models based on your specific domain. That's what AutoML is all about. So that's cloud-based inference for these three specific scenarios. But then we always get the question, OK, it's great if it's sight, if it's language, or if it's conversational, but what if I'm doing something that's unique and something different? For example, somebody asked me recently about they wanted to do network configuration, and they have these massive networks, and right now all of the configuration on these networks is done manually. Wouldn't it be great if they could see traffic on these networks and then use software-defined networking to automatically configure their networks based on a learned behavior? So there's a great example of a custom ML model. So the question then becomes, well, if I have a custom ML model and I want to host that in the cloud, what do I do? So typically, there's three main ways that you build models for machine learning. Number one is a pre-trained model. A little bit like I just mentioned, some of the services that we have in the cloud, somebody's built a model for you. Those services I showed earlier on are models that Google has built for you, but we're not the only people who build models. So the idea is that there are a ton of pre-trained models out there that you just might want to use, and you might want to deploy them to the cloud. So we have a service called TensorFlow Hub, which is on tfhub.dev, where the idea is that that's a repository of pre-trained models that might break out of the scenarios that we're hosting and allow you to have a model that then you can host in the cloud. The second scenario is retraining models. Now, earlier I mentioned the fact that there's those three pillars in my previous slide that you could retrain those for your scenario. But what if you have a scenario where there's an existing model and you want to retrain that? So for example, there may be a computer vision model that you want to retrain, but you don't want to host it with AutoML. Well, that's also possible. You'll be able to take a model out of something like TensorFlow Hub, and you'll be able to retrain that, and you'll be able to host it yourself. And I'll talk about hosting it yourself in a moment. And then, of course, there's building from scratch. You want to start from nothing. You don't want to use anybody else's model. You have a scenario that is so particular and so unique to you. And that's what TensorFlow is all about. So TensorFlow is your API that will allow you to define neural networks and train them so that you can build a model. OK, so then you've built a model, and you want to host it in the cloud yourself, but you don't want to use Google Cloud. Maybe you want to host it on your own premise. Maybe you want to host it in another cloud provider. So we have something called TensorFlow Extended. Now, the idea behind TensorFlow Extended is that it's end-to-end, enterprise-y type for building, managing, and running models. But the orange box that I've highlighted here is a technology called TensorFlow Serving. And you could just use TensorFlow Serving from TFX, deploy TensorFlow Serving to your server or to another cloud provider or wherever you want to put it, and then you can serve models out of that. So we want to just try to be able to cover every base that we can cover if you want to run cloud-based inference. So there's really three pillars. Number one, you can use a service from Google and either use that directly or retrain it. Number two, you can build your own model and host it on Google. Or number three, you can build your own model and host it anywhere you like. So those are the three main scenarios that we're trying to hit. So AutoML for the first, TensorFlow Serving on Google Cloud for the second, TensorFlow Serving on your own server or on another cloud provider for the third. And if you want to learn more about TensorFlow Extended, TFX, you can go to github.com/tensorflow/TFX. It is open sourced, and we have our website around it, which is tensorflow.org/TFX. So next up is on-device inference. Now, the idea is that Ibrahim mentioned, your choice where you're going to run your inference. Number one, you can run it on the cloud. Or number two, there was a bunch of scenarios where you may want to run it on device. Maybe you don't want to pass data up to a cloud to have it inferred on. You want to do everything locally. There's a great video out there, for example, of farms in Tanzania in Africa who rely on a cassava plant for their food. And the problem with the cassava plant is that when it gets diseased, you don't recognize the disease until it's too late. But they actually trained a TensorFlow-based model that runs on device that can actually spot the disease in a plant before the human eye can spot the disease. And all they have to do is hold their phone over it, point the camera at the leaf of this plant, and it spots the disease with 99+% accuracy. And as a result, they can root that plant out before it infects the rest of the crop. Now, this is on a farm in Tanzania where they don't have broadband connectivity, they don't have 4G, et cetera, so everything has to run on device. So that's just a great example of, like, there are scenarios where you may want to run it on device beyond just privacy and all that kind of thing. So when it comes to models on device, it's actually the same three choices. Number one, pre-trained models. In the example of the cassava, a pre-trained model is you can go to TF Hub, you can download a pre-trained model, and you can just use that directly. Then there's retrained models, and in the example of the cassava, what they did was they downloaded something called MobileNet, and MobileNet is a well-known model that's optimized for mobile use. It recognizes 1,000 classes, but then they retrained that based on leaves that they were able to categorize. This is a disease leaf, this is an undiseased leaf. And again, using the same thing that I mentioned with the activity detection, you can train it that this is what a diseased leaf looks like, this is what an undiseased leaf looks like, that type of thing. So they were able to retrain and build a model out of that. Or, of course, you can just build from scratch. You can create your own model, and off you go. But when it comes to on-device, there's one extra step that you need to do, and that's to convert your model to optimize it to run on the device. What this does is it shrinks the model, it makes it battery safe, well, not battery safe, but it makes it better for working with battery, those kind of things. So there's 4 steps in this. First of all, you build your model by either using a pre-trained, retraining, or creating a model from scratch. And TensorFlow, then you save it as what's called a saved model. So a saved model is a file format that we're standardizing on in TensorFlow 2. And the idea behind saved model is when you use that file format, it'll work on enterprise-grade scenarios in the cloud, it'll work on mobile, it'll work in JavaScript in the browser, that type of thing. To be able to get it to work on mobile, then there's a TF Lite converter, which shrinks that model, freezes parts of it, and allows you to use it on TensorFlow Lite. So you go through these steps for model conversion so that you can then execute your model on a mobile device. And when I say mobile device, we're actually moving beyond just iOS and Android. The same process will be able to be used so that your model will then work on embedded systems. So we recently released support for microcontrollers, some microcontrollers, and like embedded systems like IoT-type devices like Raspberry Pi. So let me give a quick demo of this, if we can switch to the demo machine. And my screensaver kicked in while I was talking. Thanks. All righty, so I'm actually going to run this on the Android emulator. So we can see running on the Android emulator now is like this is a little app that's running in TensorFlow Lite. So it's an open source app. You can go and download this now if you like. And what this is doing is it's grabbing frames from the webcam. It's emulating the webcam using the front camera on my laptop. And then it's classifying those frames using MobileNet. MobileNet, as I mentioned earlier on, is built to work with 1,000 different classes. So what it's doing frame by frame is it's taking the frame from the webcam, it's compressing that to the size of the image that MobileNet wants to use, it's passing it to TensorFlow Lite, it's getting back 1,000 classifications, it's picking the top 3 and then rendering those on the screen. So for example, if I hold up a water bottle, we can see, it did say water bottle. There we go. It's hard to get it right with the angle. I usually have a banana for this. I forgot to bring a banana with me, and we didn't have a backup banana. There we go, water bottle, 100%, so that kind of thing. So if I then just move this up, sometimes I put my face in it, and I don't know what I wants to say, but so we can see the inference time here. Now this is running on the Android emulator. I'm sorry if it's really small, but the inference time is about 300 milliseconds on an Android emulator. If you run this on a device, particularly an Android device that has a neural networks API installed, for example, like a Pixel, if you want to see it running on my Pixel later, I can show you. It'll do the inference in about 30 milliseconds. It's super, super, super fast. So we've been building TensorFlow Lite with that in mind, to shrink the model, to optimize it, to make it super fast for inference, so you can even do like near real-time inference like this running on an emulator on my laptop, which I think is really cool. So that's the demo. If we can switch back to the slides. So in summary, for the choices that you're facing, we realized that this was a very confusing thing. So part of what I've been trying to drive in Google is a bit of a strategy around, okay, what do mobile developers need for machine learning? And it was driven off of a flowchart like this one, and I'm sorry if it's really small, but that's kind of part of the intent, that we understand that it's very confusing. But if we think about this, if we look at the left-hand side of this flowchart, those are the options that are available if you want to run inference on the mobile. And if you want a copy of this flowchart, just drop me an email. I'm happy to send it to you, because I know it's pretty small to see on here. And if you look at the right-hand side of this flowchart, those are the options that are available to cloud developers. So the idea is, like, if you want to run inference on mobile device, there are a number of scenarios. Maybe you want to have it connected to the cloud to do your inference. Maybe you want it disconnected from the cloud. You know, those are the things on the left side of the flowchart. Ditto on the right side. Yeah, if you want to use Google services, or if you want to host your own models, those kind of things. But we also have an offering that Ibrahim's going to talk about that gives us both. So the idea is, and Ibrahim probably would be best to explain it with MLKit.
Thanks, Laurence. As Laurence described, ML options may look like a scary map at first look, because we would like to provide tailored solutions for each use case. As a developer, you want to implement these solutions together. Hence, you can use the MLKit as a single SDK. MLKit is a mobile SDK that brings Google's machine learning expertise to Android and iOS apps in a powerful but yet easy-to-use package. It comes with a set of ready-to-use APIs. We'll call them base APIs. And they work for both on-device and cloud-based inferences. They support common mobile use cases like image labeling, face detection, text recognition, and barcode scanning, to name a few. While there are all ML models under the hood, they are as easy to use as any other API. Let's look at a typical workflow of someone looking to implement a machine learning model in an app. So first, the ML expert data scientist gathers, massages, and splits the data, brings or creates a model, trains, tunes, and evaluates the model. Maybe they will have to do this in a few loops. And then the DevOps will deploy the model, and finally the software developer will actually do the prediction. But MLKit makes this way easier. You simply pass in the data to the MLKit library, and it will give you the information you need. Whether you are new to or experienced with machine learning, you can implement the functionality in a few lines of code. And it includes both Android and iOS libraries. While the on-device APIs process the data quickly and will work even when there is no network connection, the cloud-based APIs leverage the power of Google Cloud Platform's machine learning technology to give a powerful, higher accuracy results. Let's look at a specific example. As you can see here, we are building an app that requires an identifying the themes and content of an image. You will be using the image labeling API. In the card, you'll be seeing two icons here. On the device APIs are free of charge and are best suited for scenarios where you need a low latency and you might not have a network connection, and you're OK with a more coarse-grained answer. On the other hand, the cloud API calls come with a free quota, but are paid beyond that. They provide the most accurate results and are powered by the state-of-the-art machine learning tech models running on the Google Cloud Platform. But if you do have some ML experience or would like to bring your own custom models, as Laurence already described, you can do that too. And using MLKit with that, you'll be able to run your TensorFlow Lite models on the underlying framework, whether it's Android or iOS. And you'll get further benefits from MLKit since it's integrated into the Firebase, such as analytics, remote config, and A/B testing. Maybe not everyone is familiar with Firebase. So Firebase is Google's mobile development platform, which has tools for building better apps, improving app quality, and further growing your business. So with using MLKit with Firebase, we'll actually allow you to upload your TF-Lite models into the Firebase console and dynamically deploy them to your users. This means that the APK bundle size can be really kept small, since you won't be actually putting the model inside the APK. And you can do frequent rollouts without having to republish your app. And you can do further run A/B experiments. Firebase features such as A/B testing, remote config, analytics make this process real easy. And I would like to actually walk through a demo and show all these features to you. Can we? Yep. Thanks a lot. So let's start with the base APIs. This is a small sample, actually. I was using only the base APIs here. Let's do some detection. As I already described on image labeling, let's start with that. When I start using the on-device APIs, they are really fast, and I get some answers here, like beach, rock, sky, cliff, and they're pretty good. But if I want like even finer results and way better accuracy, then I can use the cloud. Here, I'm actually detecting from the cloud. As you can see now, I get like a more finer grade answers, such as body of water, sky, wave, shore, that weren't actually in the normal on-device API call. And we already described some use cases there. Maybe like some use cases where on-device APIs were better, or the cloud APIs were better. And in such a use case, let's say we are doing the face detection. We will need to use on-device APIs because we want to actually process those frames really faster.
I think you look great in lipstick, by the way.
I'm not sure. So it's a small face detection, and we get the contours. And we are using the on-device APIs here so that we can actually process these frames without having to go back to network and waiting for the network response. But as we said, like MLKit, we were able to like use even hybrid solutions because we are using a single SDK. There's another demo I did earlier. Let's see how it works. But this is actually the results coming on the top are coming from the on-device API, because I want to actually get these frames as quickly as possible.
I do use my Mac for making music, so saying it's
a
musical instrument
we'll
is
see
accurate,
about that. So I want to actually trigger it. It starts with the musical instrument, as you see. That was the on-device API. But at the same time, I did a call to the cloud API, and I was able to swap the label with a laptop with a better answer, because I was actually getting the laptop from the cloud API. I can do like few other things, as for some reason I'm getting a lot of clouds and yeah.
There we go.
As you see, like it actually changed from like the musical instrument.
Definitely.
I hope not.
Everything is a potential musical instrument when you think about it. So, you know, this is sitting, arm.
And on top of that, we also mentioned about the custom models. So you can actually bring your own model to MLKit as well on the framework of TF Lite. So I was actually using a local model here and doing the image labeling with my mobile net on model. And also I can use the Firebase to download another model from the remote. And I can use this time using the same image labeling from my remote model. This way, I was able to use another model that wasn't in the APK or in the bundle before. But not only that, we can actually further use Firebase to go one level higher here. This is my Firebase console, if you are not familiar with it, that I'll be actually using as a console for my mobile development. Here, in the MLKit section, I have some custom models. In these models, I see like the image classification, invalid models, some models that I already published, so they can be downloaded on the fly from my client. Let's say I want to do some A/B experiment. I want to see if I have a better model, if it's really better or worse, or how will my users actually will react to this new model. We can actually run an A/B testing. An A/B testing lets me use some of these models or some of the other parameters on the fly to my app. We'll use a remote config, which will actually, my clients will be able to get some configs on the fly again. Let's say the ML experiment name is MLKit, just for the sake of example. And here, I will be selecting my app. For the sake of example, I'm just going to say 5% of target users, which I'll be rolling my new model. And I want to have some goals so I can track some metrics that if my new model is successful. Let's say daily user engagement, one of the common goals, the most used rules here. So I will be creating some parameters so I can change these models on the fly. Let's say ML model name. And one of my models is image labeling. And I can create a new experiment now with a different variant. So the 5% of my users can actually get the version 2 model. With that, I will be starting an experiment. And I'll be a quick review here. And from now on, I can actually start the experiment and see how my users will react. Through the experiment, I can see things like that. If there's a better user engagement with this model, or maybe my users are actually having a lower churn rate, or if I'm selling something from my in-app store, maybe they will be actually getting more stuff because actually they really found what they were looking for using the ML model. Can we go back to slides? As I explained, this was I just started this experiment, so I won't have the data ready. But there was another one, actually. I did an experiment before. Here, I can see clearly with different variants that one of the models actually ended up having a lower user engagement, and the other model made my users actually stay more. Maybe they really found what they were looking in my app using this new model. So using these experiments, I can really find the best model I can use, and I can even process and get better models to go from there. As Laurence already described, as Google provides so many different options. Either you are a new or experienced ML developer, or you want to do your inference on the cloud or on the device. And if you want to bring your custom model, or you want to use the Google's model. And with ML Kit, we can actually use it from a single SDK. And it's as easy as sometimes, if you want to use the base APIs, a few lines of code, or you can bring your own model as well. And you can further use Firebase to get analytics and to actually match your different ML models and see how they perform.